Two interesting functions are lvalue and rvalue. We're going to go through each. Let's look at first lvalue. What we're trying to find is an address for x, where x equals some value. Let's call it a. So x is on the left, so it is the L value, or we need to get the L value from the variable named x. Okay, so x is this x here, and it's going to be an expression. So in the simplest case, x is just an identifier, and in which case we could just return x and we'll be able to go into that node and get the address, and so we're done, and it's easy. But let's say that x is an access, which means that it is an array. So the array is actually the y, and the z is the index. Okay, and if that's the case, then we want to get the r value for z. So z can be an expression, right? The index can be expression. For example, if I say like array I plus 1, that's an expression. And so we need to get the r value there for that. And then we can get the address of that array and return that, and we're golden. Okay, so that's getting an L value. What about an R value? And in this particular language, R values can be a little bit more sophisticated. So in the L value example, we had x equals a, x is L. But here x is the R value, and so we're looking at something like a equals x, where x can be an expression. Okay, so again, the simple case is when x is an identifier, or in this case it can be a constant. Over in the L value, x cannot be a constant. We can't assign a value to a constant. Okay, so if x is a constant, we just return x. Now, what if x is an operator? So what are we looking at there? We're looking at something like, say, a equals maybe y plus z. Or possibly, well, yeah, let's just start with that. Okay, so x is an operator node. So in this case, x would look like, not that. X would look like a plus node with y and z, or identifier children. And that's what this is right here. And so if it's an operator, then we're going to create a new temporary address, and we're going to emit a string to assign the r value of y with the operator and then z to a temporary value. So essentially what we're going to do is we're going to emit 3 address code that evaluates y plus z and puts it in a temporary variable called t. And we're going to create a new node for t. So we would emit something like t equals y plus z, and then we would return that t. Okay, so super straightforward. Now, what if x is a relational operator? In that case, we're looking at something like a equals y is less than z. And so the node in the syntax tree is going to look something like that. And we're going to do something very similar to that. We're going to emit code that evaluates this y is less than z, and then return t, the temporary variable. Okay, so now what if x is an access or an array? So here we have the array, and here we have the index. All right, and so in this case, we're looking at something like a equals array I would be the original code. And in that case, we're going to call lvalue on x and that'll return us the value for the array access. Then we assign that to a temporary variable t, and we return a node for t again. So same type of idea. Now, we don't see this one very often. X is an assignment node. So this would be something like a equals y equals z. And we just generally frowned on to do stuff like this just because it's not common and programmers aren't used to seeing it, but it can happen. And so in this case, we'd get the R value for z. We would then emit the string to get the L value for y, and then return the R value for z.